These are notes on gel electrophoresis. So this is a method of separating things. So you're aware of different ways you can separate things, right? So like if you had things you could see, like M&Ms, you could simply separate them by hand. The red one's over here, the green one's over here. Some of you have done chromatography, where you've put like a little dot on a piece of paper and then let water go up the paper and it separated it into different pigments. Some of you may have done a sand and salt separation, where you were able to separate the salt from the sand because the salt is water soluble and the sand is not. So lots of different ways to separate things, and gel electrophoresis is another way. And the main thing we separate with gel electrophoresis is segments of DNA, but we'll get into that in a few days. What we're going to separate in class to start with are different dyes. So we're going to different colored dyes, and we'll separate them into their specific pigments. And we'll learn some stuff about those pigments along the way. So this is a gel electrophoresis setup. And so this here is the power supply. So in the directions, and I highly recommend that you like have the directions, the lab protocol somewhere in front of you, either on your computer so you can switch back and forth, like pause the video or print it out. But when it talks about plugging into the power supply, that's the power supply. And this is where it tells you how many volts there are. And then this part here is the gel electrophoresis box. Okay, and then this in here is the actual gel. So when we're talking about gel electrophoresis, that's where the gel is. And then there's liquid on either side, which is called a buffer. And that helps the current go. There is a black lead here and a red lead here. And the black is the negative lead, and the red is the positive lead. And as you may remember from physical science, opposites attract. So if it's a negatively charged particle, it's going to go towards the red lead. If it's a positively charged particle, it's going to go towards the black lead. And when we get to DNA, we'll talk a little bit about whether DNA is positive or negative. But this is the basic setup that you're going to use. And then these guys here are little wells. So they're actually little holes in the gel, and you can put stuff in them, and then when you turn on the electricity, they get pulled through the gel if they are electrically charged. So that's the basics of what is going on. And so you're going to put different dyes in these holes. One big difference is that for the dye lab, your holes are actually, or your wells, let's call them what they are, your wells are actually going to be in the middle of your gel. Okay? And we'll talk about why that is a little later. So here's me last summer, or yesterday, as the case may be, that kind of can show you what you're doing. So this is step 3B in your protocol. So if you're looking at it, look at what it says to do in step 3B. And here I have a little microtube, and then I'm holding what's called a micropipette. So micropipette, it's a pipette, but it discharges incredibly small amounts. So I think your protocol calls for 20 microliters. 1 microliter is 1/1000th of a milliliter. So you can imagine how small this is. And I'm going to teach you in class how to use the micropipette so that you know how to get your 20 microliters. So here I'm drawing up my however many microliters. I don't remember exactly what I was doing with it. I think probably 15 microliters. But anyway, I'm drawing it up out of the little microtube. And then I'm going to put it, I have a gel in here that you probably can't see, into the little well. So it's just like using a pipette, except it's a really small, very precise pipette. This is me demonstrating without an actual gel box in front of me because I was doing this at school. I guess this was actually today. But I wanted to show you the procedure for putting it into the wells. So you'll notice I'm holding the micropipette with one hand, and my thumb is on the plunger here. Same here. But then I'm actually stabilizing my right hand, I'm right-handed, with my left arm. And you need to be really, really precise and accurate when you're putting stuff into the wells, because if they don't go in the wells, or if your hand shakes a lot, then it's going to get stuff everywhere and it's just simply not going to work. So that's the kind of the setup you want to use, is you want to hold one hand and plunge with the other. And you might think like, well, I'm good enough, I've got really steady hands, I don't need to. I spent some time working in a lab last summer, and I can tell you anybody in a lab absolutely holds their hand to steady it. That is exactly how, quote, real scientists do it. And so once you've put in all your dyes, and this here is a box of tips, and the tips go on the end of the micropipette. So the micropipette ends about here. So then there to there is all tip. You're going to use a different tip for each dye. So that's a validity measure, right? A clean tip. You don't want to mix your dyes because that's going to screw up your data. So then you plug in your leads, you close your box, you plug in your leads. It's pretty simple. You let the gel run. And in the end, you should actually get something that looks almost exactly like this, since we're using a lot of these same dyes, although I may have different mixtures. And you can see here my wells in the middle, and some of my dyes ran towards the negative, so think about what that means about the charge of those dyes, and some of them ran towards the positive, so think about what that means about the charges of those dyes. One thing I want to point out is if we look here at just the negative side, so this dye, and this dye, you'll notice they all ran different distances. So this light blue one got the farthest, this purple one didn't get very far at all. That's going to tell us something about the size of those dyes. So if you think about it, these dyes are molecules, and they're trying to get through this really thick gel. So think about it as people running through a forest, but some of them are holding hands with other people, and they're all running for the same amount of time. But the ones that are going to get the farthest through this forest are going to be the ones holding hands with the fewest people. So the smaller molecules can get farther through the gel than the larger ones in the same amount of time. If we ran it even longer, then this gel could go even further, but so would this. I mean, eventually they could all end up, well, quite frankly, running off the end of the gel. But this is how you can tell size of the molecule, because the ones that get further away from the wells are the smaller ones. Okay, so now you have sort of a basic introduction in how to use gel electrophoresis. And so please make sure you ask any questions in class, and this is what we're going to be doing on Wednesday. Have a good night.